Thank you very much.
How are you?
Good. How are you doing?
I'm so surprised. You're so young.
Oh, I appreciate that. Thank you. I'm older than I look.
Oh, really?
A little bit.
Can I ask, how old are you?
How old do you think I am?
35, 34? Or,
oh.
No, you look 28, but 28, 27?
29.
29?
29.
Ay, büyük rezalet. You said, I'm older than you think. That's why I said 35 or 34.
Okay.
But you look 27, 25.
Thank you.
But still, you look young.
I appreciate it. Yeah.
Let's hear you, okay?
All right.
There
Thank
you
you
go.
very much. I appreciate it.
Büyük alkış lütfen, büyük alkış.
Thank you. Thank you very much. So now we're going to talk about outer space. All right? So, in the news recently, how many have seen this? So here, awesome, a lot of people. And I don't know any Turkish, so this will all be in English, by the way. So here we have the first ever image of a black hole. So what we're looking at is the event horizon of a black hole. Now this black hole is in galaxy Messier 87, which is up here in the corner. That's at the heart of that galaxy. So what we see here, this orange colors that we see around this black hole, that is not the actual color of the black hole. What that shows is an intensity of dust and matter, a lot of stuff that is around the black hole, but not the actual color that it emits. So the really innovative thing about this image is how we were able to capture it. So we used an array of telescopes around the world called the Event Horizon telescopes. They're from all around Earth, all synced together with atomic clocks, which is how we got the data to play together nicely to create that amazing image of the black hole. If you want to hear more about black holes, Dr. Umut Yildiz is an expert. He's an astrophysicist. He will be coming up later. Hear for him. Over there, that guy. So my expertise is more on the spacecrafts, building and designing the vehicles that are exploring our universe. So something that we did just recently was we landed this one, Mars InSight, on Mars earlier this year. So what we have over here, this is a seismometer. A seismometer is something that detects movement. So here on Earth, we use a seismometer to detect earthquakes, stuff being rolling around. I live in Los Angeles, we get those all the time. So we're listening for Mars quakes. We're studying the interior of Mars. We want to know how active it is, how much movement is going on inside. New innovative things that NASA's just starting to receive data from. We're taking in all of these science measurements and starting to study, and we think we may have heard our first Mars quake just recently. So it's really exciting to see all the innovative research that's coming out of Mars InSight. A very impressive feat went along with Mars InSight. MARCO stands for Mars Cube 1. They're CubeSats. It's a spacecraft about the size of a briefcase. You can hold it in your hand. So we sent 2 of these all the way out to Mars. That is the first time ever that there has been an interplanetary CubeSat. So we have 2 images down here on the bottom of the screen. The first one shows a picture of Earth and Mars that MARCO took as it was flying away. And that second one there, that is Mars. That is a picture of Mars from a CubeSat that was taken and then sent all the way back to Earth. That is an amazing feat. A lot of scientists and engineers needed to come together to collaborate and innovate to create this type of capability. Now, Europa. Show of hands, who has heard of Europa? Not as many people. Awesome, I get to teach. So here we have our solar system. We have our 8 planets. So let's look at Jupiter. So Jupiter has over 70 confirmed moons at the moment, but here are the 4 largest ones. We have Io, Europa, Ganymede, and Callisto. So Io is the most volcanically active body in our solar system. There are volcanoes erupting all the time. Now Europa, we're going to dive into that one in just a second. Ganymede is the largest moon in our solar system. It is actually larger than the planet Mercury. Okay? And Callisto. Callisto, we believe, is one of the oldest bodies in the solar system, and we can tell that by crater dating, or you count how many impacts there's been, how many dents are on this moon, and it has a lot of them. But Europa, that's the interesting one. Europa has the most potential to find aliens in our own solar system. Now, when I say aliens, I don't mean these big aliens. I mean really tiny little things, tiny little microbacteria. So Europa is about the size of our moon here on Earth, but it has almost 2 to 3 times as much water as all of Earth. The reason being is Europa is just like a big ball of water that's frozen on the outside, possibly a 30-kilometer thick ice crust with a 100-kilometer deep ocean. Now compare that to Earth. Earth's ocean on average is 3.5 kilometers deep, with our deepest point being the Challenger Deep in the Marianas Trench, right around 11 kilometers. So as big as Earth is compared to Europa, it doesn't have that much water, but it does cover a lot of our surface. So why is Europa the best place to find aliens? What's so special about it? Well, from what we know about life here on Earth, you need 3 ingredients for life. So you need water. Where we find water, we normally find life here on Earth. So Europa, it has it. We can check that box. We've learned from Galileo and from Hubble telescope of the saltwater ocean that's underneath that ice crust. Number 2, we need chemistry. We need the building blocks of life, the stuff you find in rocks. We need carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, abbreviated SCHNAPS. That's how I remember it. So we need the right combination of those elements to form molecules to give us life. Now the last one is energy. We need a way to power life. So here on Earth, we've got this big ball in the sky called the sun, which gives off light energy, and plants use the sun's light for photosynthesis, and that's how they derive their metabolism. But Europa out at Jupiter is so far away from the sun, the sunlight drops off so quickly that it's just not the right source of power. So what's going on out there? Well, those moons I showed you before, the 4 big ones, they're all in a little bit of a match, like pushing and pulling each other, which causes Europa to flex. So it gets bigger and then gets squished, gets bigger and then gets squished. And what this does, this is mechanical energy. All right, so we're moving, it creates heat with friction to lead way to things that may be like hydrothermal vents, or like underwater volcanoes, like we see here on Earth. We're not 100% sure, but it's a thought that that might be what's going on out there. So we find life around these hydrothermal vents here on Earth, down in the Marianas Trench. So they use something called chemosynthesis, or chemical energy, to derive their metabolism. And we think that that process may be going on out at Europa. And with the combination of these 3 ingredients, plus in the center there, habitability, we believe it's been around enough, it's stable, that all of that combining can give us a good environment to foster life, life as we know it. But really, why is that so important to find life? Are we alone in this universe? Is that the really big question? I'm going to quote the pre-project scientist for Europa Lander. He says, "Physics has been proven everywhere throughout the universe. Chemistry, we've seen throughout the universe. Geology, we've seen throughout the universe. But we have not yet found biology off of the surface of Earth, on another planet, somewhere else. So we need to find that biology. See if there is another life form out there that's like us. Is it carbon-based? Is it silicon-based? Is it life that we don't even know how it operates? So we're going to send some spacecrafts out there. The first one we're going to send out, this is Europa Clipper. It is going to launch in 2023, so we got 4 years. And this spacecraft is going to orbit Jupiter, and it's going to fly by Europa. So in the middle there is Jupiter, and the radiation environment is so intense around Jupiter, electronics don't like radiation, is that we're going to fly in, take our data of Europa, and then go back out to the normal radiation of space. We're going to do this 45 times over the course of 2.5 years so that we can get everywhere around Europa, like you see on this far right image. So I'm going to play that one more time. So we're going and we're swinging in. We're coming by Europa really fast to take our data, about 10 hours, and then we leave Europa's really intense radiation environment, and then we have about 14 days to charge up our solar arrays, to get our batteries more full, to send data back to Earth, to get ready and gear up to come back again and take another look at Europa's surface. So each time we go in and we do one of those flybys, it looks like this. These colored bars coming on are different science instruments or devices that are turning on, like an ice-penetrating radar. Let's look through that ice, see how thick it is. There could be cameras taking pictures to look at the surface to get a better understanding of what it looks like in a high-resolution aspect. So we'll take a look at it again. So we start approximately 66,000 kilometers away from Europa, looking at maybe a magnetic field influence, doing some remote sensing to see what we can truly learn. And then when we get close, we take pictures. That blue and purple is taking pictures, creating a stereo image for potentially having a lander in the future. So that would be really neat. So Europa Clipper is looking to confirm the habitability hypothesis I mentioned earlier. But to see if we actually can find life, we're probably going to have to get down on the surface. So NASA asked us at JPL, the Jet Propulsion Lab, to look into a lander. If we were to do a lander, what would it look like? How would we do it? How much would it cost? So it's not officially going to happen yet. Hopefully it does someday. We're working on it. They're continuing to do research to figure out what it would be. But the latest concept of if we were to land on the surface of Europa would look something like this. So if this thing did go forward, we could maybe launch in 2027, but we would land this on the surface. And what's really difficult about landing on the surface of Europa is it's kind of like landing on the surface of the moon where there's no atmosphere to slow down. On Mars, we use a heat shield to slow down, we use parachutes, and then we have a sky crane, which is what we use for Mars Science Laboratory, or Curiosity, to lower it down to the surface. We can't do that at Europa, no atmosphere. So we're going to come in firing hot, and then we're going to possibly shoot a rocket this way to slow us down, and then we're going to do that awesome sky crane thing to lower the lander on the surface. That's one way we could do it. So what it looks like here is this: we have a big metal box with all our electronics to protect it from the radiation. Then we have a robotic arm with a saw and a shovel on it so that we can saw down into that ice and then use the shovel to scoop some out and put it inside that metal box. So our science devices can look at it and analyze, see what's inside of it. And then we have an antenna. This square thing on the top is what would communicate directly with Earth. There wouldn't be a relay asset in this configuration. We would send our data right back to Earth. And I mentioned earlier that the sun is so far away from Jupiter to survive, to give life. So that means solar panels are really hard to come by to give us energy. So this mission in this configuration would be completely battery powered. So you turn on the batteries as soon as we get on the surface, and then we could be alive for maybe 30 days, maybe 20 days. Depends how much energy we use. So we need to come up with really innovative ideas and concepts, collaborate with people from all over to figure out what is the most efficient way to do this in an effort to find those biosignatures of life, looking for the carbon, the hydrogen, the nitrogen, oxygen, phosphorus, and sulfur. See if we can find those things to tell us maybe there is life within our own solar system. We just have to go out there and find it. It might be waiting for us. And if we do find that life, then we have the answer to the question, are we alone? Is biology universal? Does it work everywhere? Personally, I think we will find life when we get to Europa. I believe in it. I have to. It's what I think is the most important aspect of my job, is being truly passionate and believing in what we're going forward with. So thank you.